like to pick up with page 109. If you do still have it and you know where it is, you might want to take it out if you want to check anything here. Actually wanted to talk to you about some things. Maybe you're aware of this. Maybe this will sound kind of new. Just kind of how'd you do? Number 32 is sometimes an interesting problem. Did you factor it correctly? Or did you look at the graph correctly? If you did a factoring method, you would have pulled out an x squared, and then you would have been left with a trinomial that you would continue to factor. Just kind of draw your attention, number 32. How did that go? Did you get all 4 of those answers? Did you actually list 4 answers? Which brings up this idea of multiplicity. Maybe you saw that in the directions. I hope that you remember that I said the word, and some of you talked about multiplicity when you did your little word splash, but for most students, it's kind of like, what is that again? And so I want to use this homework as almost a continuation of the lesson and give you guys a little definition of multiplicity. If you want to write it down, you can. If you just want to remind yourself. If you've never heard of it before, it's just the number of times that a root is counted. So multiplicity is one of those polynomial ideas. It's kind of specific to these types of problems. Don't worry if you didn't talk about it in your homework. I didn't really check that, but I am curious, do you understand that a lot of these problems, well, all these problems have some type of multiplicity. Now, sometimes something like this becomes more evident when students see that the x equals 3 is counted twice. It shows up twice. We need it twice. And so we would say that x equals 3 has a multiplicity of 2. By the way, so do some other answers. But I'm just pointing out that on this one, x equals 3, well, it only shows up one time, which isn't really that abnormal. But since it only shows up one time, it has a multiplicity of 1. Again, multiplicity is really just kind of a fancy word for how many times a root is counted. Okay, and as you can see, some of these other answers had special multiplicities. Now, kind of purposely, I'm not saying too much more about that, but there are some other ideas with multiplicity that relate to polynomials. And what I'm going to do is to get you guys to kind of think about these / remember these or learn about these is to give you what I call a little class challenge. Now, I guess we've probably never done a class challenge before. Basically, I'm going to give you guys a problem, and I'm going to kind of challenge you to, as a class, to see if you can successfully answer it. Now, the answer to the problem is going to be that you're going to end up trying to list everything that is significant and true about a certain polynomial that I'm going to show you in a second. Okay, so the class challenge is to see if you can basically observe and list everything that is true and significant. Okay, now the way that this kind of looks, just so you know, because I don't think we've done this before, is that I'm going to kind of disappear. I'm not going to be involved in this, at least for the challenge part. We've got a blank slate, literally a blank slate up here. And as a class, if you guys can list the items, which means you're going to have to write them down. So it looks like some kids will be like coming up to the board. You're going to be talking. Do that freely, okay? And basically, somebody's going to have to break the ice and sort of come up to the board. Now, if something gets written on the board that you think is good, obviously leave it there. If you're kind of like, as a class, if you're like, wait a minute, that's not right, be nice, and you can erase it. If you don't know if it's true or not, you could leave it up there. But you're going to have to interact, and you're going to have to kind of get going because there is a little bit of a time limit. Okay? Now, I'm going to show you a polynomials graph. I'm going to show you the graph of a polynomial. And it is the graph that I'm asking you to look at. Use some thinking from other years. Use some thinking from even the lesson the last time that we were together remotely, and be thinking about the things that are true and significant about this polynomial. Now, just so you know, I'm not trying to like trick you. with the window, I did a little bit of zooming in on the x-axis. So the x-axis is kind of squeezed in, but the y-axis is a little bigger. It's not really a big deal. I mean, if you want to write that down or if you want to change your window, this isn't just purely a graphing question. It's for you to look at the graph and see if you can state what's significant. Do you get the idea? Okay, so the chalkboard's empty, but I hope it gets full. You've got a class full of sort of classmates, and the challenge is to see if you, and by the way, if you kind of succeed on the challenge, we dangle a little bit of bonus in front of you. If you don't, it's okay. We're still going to learn from it, but actually, I enjoy this kind of thing because I will give everybody that participates a little bit of bonus. Okay, without further, here comes the polynomial. All right, so ready, set, go.
All right.
Oh, my figurative whistle here. The horn has blown. The game is over. Did you win? You actually satisfied kind of the minimum of the class challenge, which is really good. You're going to get some points, which is fun. Let's talk about what you have up here. Maybe you're like, well, what am I missing? And of course, if there's something up here that you're not sure about, let's talk about that too. I still want to see this. So let's see here. It was the first thing that was written. So how did you know it was degree 4? How did you know it was degree 4?
The x minus 3 point, when it bounces off and doesn't like cross, that's squared. When it just goes straight through at the origin, it's 1 and then same right there. So really,
Okay, so we definitely have a connection here, and I hope that you guys realize that these go together, and exactly right. Now, this does bring up something that somebody said. Maybe you were like, yeah, it's no big deal, but it's a big deal. I heard somebody say multiplicity. You know, it's actually a word that I was using up on the homework, but this, as Caleb was saying, it has a different behavior right there. And to that you guys realize that is really good. It's probably more of a hats off to last year, but -3 seems to count twice, and you're right. Now, let's kind of go back to that real quickly here. You used some language. You said it sort of just bounces off. Sometimes we'll say it just touches. It just touches at x equals -3. In fact, a polynomial also can tell us a little bit about human behavior, even at the high school. Specifically, that's the only kind of touching that we want to see at the high school. Okay, so whoop, it didn't like that, but no, there might be other kinds of touching, and you sort of have my permission to go up and say, no, no, no. My math teacher said that that's the only kind of touching that we want to see. Okay, now it's kind of a corny joke, but when you see it, you realize that it's a different multiplicity. By the way, the other behavior, kind of like Caleb said, it passes through. Sometimes we use the word crosses. It just crosses the x-axis. That's kind of the regular behavior. You have a multiplicity of 1. Okay, that's a nice job. What else can we talk about? Jace, you were putting down these factors. Did everybody sort of, were you a part of what happened here? You originally had x plus 3, x minus 3, and that's fine. You can simplify that to be x squared minus 9. But the truth is, every root up here has a factor. Pretty basic stuff, but that is significant. Of course, the equation, -x to the 4th minus 3x to the 3rd plus 9x squared plus 27x. Did we experience that? I don't know if there's much more to say about it, because I would assume that you guys took your factors and multiplied it out. But you do see, I hope you see, that there was a negative said to be out front. Why? Someone other than Caleb, why is there a negative out front? Now, what you just said there is true and significant. The graph is going down as an end behavior. And I'll share with you, as soon as this got up on the board, you guys satisfied the minimum of the class challenge. This is definitely good stuff. This is called end behavior. And sometimes I call it sort of the infinity box. Not the infinity stone, but the infinity box. And you basically have some statements about the ends. Now, x going to infinity is to the right, and the graph goes down. X going to negative infinity is to the left, and the graph also goes down. How come the graph goes down on both sides? Don't say because that's what it does. Why does the graph go down on both sides? This would have put you at another tier, but can you talk about it now? It does have to do with the degree. Something that, anybody want to add anything to that?
I guess just how the even degrees go in the same direction and the odd degrees opposite.
Even is the same, odd is opposite. By the way, I'm going to have a little summary slide of this, but if you're kind of like, I'd like to write that down, good job. I'll show it to you in just a second. So that's a nice add-on, right? Hey, the domain and range thing, it's fine, it's right. I'm going to say it's not significant, but that's fine. Don't take that the wrong way. But it's good stuff. It's right. The Y-intercept is kind of special. I talked about it in the last lesson, and it's good that you guys noticed that the Y-intercept. Did you notice? I know you see it up there, so that's good stuff. Anything that's written up here that you're like, how'd you get that? Anything to add to it? We could talk about absolute maximums and minimums. It turns out that we're not going to, but if you're thinking about that from polynomials, definitely that is true. And that's fine. There's no reason you would have known otherwise that we were or weren't, but the graph actually has some maximums and minimums, which have a little connection to the range, right? At least the one maximum. I made a slide that is meant to at least show you what we said verbally. You decide if you need to write it down or if it's like, yeah, I remember this, but I still want to show it to you. So we did say this a couple times. We have like a growling sound. It's this idea of either crossing the x-axis, or being tangent to the x-axis. Now, actually, I'm not sure. Did I mention this odd or even? Maybe I forgot to mention that, but odd multiplicity is going to be a cross. Even multiplicity is going to be a tangent. Don't feel like you're the only one. If you're like, I'm not sure what you're talking about, I just kind of get a feeling sometimes on this one. When we talk about multiplicity, we're talking about the behavior of these x-intercepts. I didn't use that word tangent. I guess I joked and used the word touch, but tangent just means that it's touching versus crossing. And the truth is that it actually doesn't have to just be that it counts twice. I mean, it could have counted 4 times. That'd be another even number. Usually it doesn't, okay, but it could have. And then these ones right here only counted once, but technically it could have counted any odd amount. So I could have had 3 zeros. I could have had 3 threes. If you're like, well, how do I know? You don't know. You actually don't know. And that's why we just default to kind of like either counting once or twice. But technically, it could count any even or odd amount of times. End behavior. End behavior. There's actually 2 parts to this. Okay. Did you realize, as we talked about it, that the degree, that was the thing that Jace was talking about, the degree is going to tell you if the end behavior is opposite. So that'd be an odd degree. And maybe you remember the teacher saying odd for opposite. That's an easy way to remember it, odd for opposite. And then even degree is going to be the same behavior. The problem that we did was even. That's why both sides are going down. That's why both sides are the same. Okay, and then one more thing, which again, maybe you remember all this, which is fine. This is what Caleb was kind of giving when he talked about the leading coefficient, and Andrew said that the leading coefficient is negative because it's going down. So again, the leading coefficient tells you what's happening to the right, which is, as we know, x approaching infinity. Okay, now what I'd like to do, and it won't take too long, but I'd like to kind of take these ideas and basically keep doing the same thing, but not like a class challenge, but just putting them all together. Hopefully, if there's any uncertainty, or if you're saying, is this what you mean? That these simple examples will help you to work this out. Let's see what we want to do here. Let's create P of X. Let's graph P of X. Basically, let's try to understand P of X. If I tell you that the roots are as follows. I did write down the number 0 3 times. As you hopefully realize, that is not like a typo. And then we have 3 and negative 3. Okay, now there's not supposed to be any trick to this, but it is to realize everything that we talked about, even the last time that I taught you remotely, is what's going on here. Definitely every one of these roots has a factor. Now, you wouldn't need to write out x times x times x. That is, if you were already thinking about writing that xxx as x to the third. So yeah, you can get there as quickly as you can, but technically 0, 0, 0 is going to be x to the third. And then here we have this x squared minus 9, actually kind of looks like the one we just did. But you always want to write this in standard form. And so yes, you keep distributing, and it's not too hard to distribute and get x to the fifth minus 9x to the third. Hey, don't forget that the exponents, sometimes we forget, but don't forget that the exponents, well, we added the exponents. Okay, and that reminds me of a little story about my family. When my first son was born, I told my wife, honey, Adam. Honey, Adam. We named our first son after this property. Luckily, we didn't name our second son after that property. We just gave you a regular name. Okay, but don't forget the Adam property. What else is going on here? Degree 5, right? Degree 5, not really that surprising, as we obviously had 5 roots up here. Let's think about the graph. When you guys think about this graph, I hope that you go right to the x-intercepts. I hope you go right to the x-intercepts and think about the end behavior. Now, the end behavior is kind of twofold. Yes, it's the positive leading coefficient. And maybe some of you will like this. Maybe you've done it with other teachers, but when the leading coefficient's positive, I already know that the graph's going up. I didn't draw the rest of the graph, but I did draw it going up on the right. And of course, this degree is odd. So since it's odd, we know that the other side is going to be the opposite. We know it's going to go down. So sometimes I like to just kind of draw the two pieces. Some kids like to do that also. But before it's all said and done, you need to connect the dots. And really the idea here is there's only one way to connect the dots, and that is by crossing each of those x-intercepts. By the way, this was an odd multiplicity. Odd multiplicity crosses, but of course it needed to so that we could finish our graph. Let's do one more. Maybe that's a little bit more intriguing. This time I'm just going to generically say, let's analyze this P of X Now be careful, I wrote negative x times x, the quantity x minus a squared. Yes, that's an a, x minus a squared. You say, well, what do you mean analyze? Well, just kind of understand everything that's going on with this polynomial. And so maybe the roots are one of the first things that you think about. Fine. Okay, just to make sure that we understand that this x out here definitely gets a root that goes with it. This x minus a, it actually shows up twice, doesn't it? So that root gets counted twice. Sometimes students will say, do I have to write it twice? Yes, unless you want to say multiplicity of 2. That's more writing, but you could say multiplicity of 2. How about the degree? The degree. This is something that's important, that you realize that that implies the overall degree. In other words, if you actually multiplied this out, now you don't have to multiply it out, but if you multiplied it out, I hope you would recognize that this is going to be degree 3, x to the third. Let's go to the graph. Let's go to the graph, which kind of puts it all together. Maybe you're a little bit wondering about that a. Well, let's put 0 down. But yeah, x equals a. That can just be an x-intercept. Okay, we don't really know where it is, but it's something positive. And of course, we now know, or we also know, that the leading coefficient is negative. Since the leading coefficient is negative, we know the graph has to go down to the right. Here we have this odd degree, which means that the other side is the opposite. Okay, and hopefully sooner than later you feel like you can connect the dots. But the cool thing is that it has to touch at a, it has to touch at a, and it has to cross at 0. Okay, and that's the only way that we really could draw this polynomial. You probably noticed that the homework is actually more of a graded homework. So yeah, instead of saying, well, what I'm saying is let's use our time efficiently here, and I'm going to go ahead and just give you the grade. Okay, it's a take-home mini check.